Okay. Question 1. We should have all said that this was a quadratic. Is that what you said? Quadratic function. Sometimes you might hear it called a square function because it's x squared, but it is not a square root. It's just a square function. The domain is always all real numbers because it's a U-shaped graph pushing outward from side to side. So it can go, kind of think of it like east and west. On the x-axis, it can go as wide as it wants to, but it cannot go up and down as far as it wants to. It has a ceiling right here at 4. All the y values are below that. I can never go up to 10, right? So if this is a projectile, the projectile never gets to a height of 10 feet. It maxes out where? At 4 feet. So you'd say y has to be less than or equal to 4 is your range. The parent function on number 2 is a square root function. Did you guys write the name or did you write the actual function? Square root is that function. X squared is that function. So this is a square root graph. Domain. This is kind of like a ray if it was a line. It starts here and it's going forever to the left. So my x values are less than or equal to 0. They're only going to the left. I can't get over to the first quadrant. And then my range, I don't know, did you estimate that this was at 1? That y has to be greater than or equal to 1. It's not very clearly marked. It probably looks like it's about 1 or 2, maybe. So all my y values, they start there and they only go up. I can't get down here. There's none of my graph is down in that bottom half of the graph. What type of function was number 3? Cubic or cube. Yep, cubic function, x cubed, one of those things. Domain and range is always all real numbers for this function because I can push out side to side because of the arrows, and I can push up and down because of the arrows. So even though it doesn't look like it, this graph really is getting wider and wider and wider and wider. Number 4, what's the name of this one? We looked at this one yesterday. Absolute value, or the brackets around the x. Its domain is all real numbers. It's pushing side to side as far as it wants to, but it cannot go lower than what? The lowest it can go is -2 on the y-axis. All the y values are above that. So y is greater than or equal to -2. Did some of us get this? Or now that you saw the first couple, do you want to take a look at your 5 and 6 and make any changes? Number 5 is actually supposed to be a ray that starts at 0, 0 and then goes in that direction. It isn't supposed to be an arrow in both directions because it's talking about the price based on the weight of something. So maybe the weight of hay, or the weight of corn. What's the price that you're paying for your shipment? And it would make sense that your weight can't be negative, right? You can't pay a negative amount for a negative amount of hay or something like that. So which kind of function is this? I already said it's a line, right? Linear. So my domain starts at 0 for weight and then goes up forever, right? So x is greater than or equal to 0. And then my price is y, and that's also greater than or equal to 0. Right? Because there's supposed to be like a dot right there. It's an application problem, so you can't have a negative weight. And then what parent function did you say for number 6? It's a downward curve. So I would have said exponential and specifically decreasing. At least if you got exponential, you were on the right track. I kind of would have looked at this like this is a dot up here at 0, 100, and this is kind of a dot. It's kind of hard to see, but it looks like my x values go from 0 to 300 on the x-axis. If you said all real numbers, that is the parent function. So if you wanted to keep it, that's fine. But I would say x is between 0 and 300 because it's an application problem. Carbon dioxide something time. I can't read it. It's too small. Does anyone know what word that would be? I don't know. What happens to carbon dioxide over time? Years after something. Don't know. The range. it looks like it never gets lower than this number right here, right? 20. So my y values stay between 20 and 100. If I was going to put like a wall up, what do my y values stay between? Or I think of it like I'm opening a window. So if I open my window, how wide does the window open in this direction, and how wide does the window open? And if you do that with your hands, maybe it'll help you visualize the domain and range. So we said 20 up to 100 would be our range. And remember, if you forget what domain and range are, you just keep thinking, when I write my coordinates, X, Y is in alphabetical order, and domain and range are also in alphabetical order of who they go with. All right, so I wanted to go backwards to 201 because yesterday, I don't think everybody, I hope that you got through 1 through 16, but I don't think everybody got through 17, 18, and 19 in this class. Is that true? Did some of you not do 17, 18, and 19? Okay, so I wanted to do those together and then draw some conclusions. If you didn't get through, how many of you got through all of 1 through 16? You got all the way through 16 done? Okay, so at least if someone near you has completed 1 through 16, let's just focus on 17, 18, and 19 if you didn't get a chance to. Who needs the calculator? You have a calculator? You need one? You need one? You have one. Wait, this is probably stuff, right? So you don't need one here. You have one in your bin. You need one. You need one. Do you have one in your bin, or do you need a calculator? You do? You have a dinosaur. You need one? That one? I would just use it till it dies. Or here, I'll trade you. I'll use the one that's dying. I tried to charge them because a lot of them were dying. Okay, let's take a look at 17, 18, and 19. Was everybody, who else was here, not here yesterday? Did everybody else have the experience of going in and trying to see what the different transformations did on the calculator? Okay, so let's just look at these couple. So we want to compare the square root function with the negative square root function. So we're going to go to our y equals menu, clear out whatever is in there. And the square root key is over the x squared button. So you hit the second blue key, and then you hit square root symbol. Second square root. So I want to compare the square root of x to the negative square root of x. And make sure you use the negative key. It's the little white key, not the big subtraction button. I don't know who used this calculator last, so I'm just going to hit zoom 6. The blue graph is the original square root function. We looked at this parent function yesterday. The red part of the graph is what happened to it. So how would you describe what happened to it? Is this your pen or my pen? Okay. Does anybody need help getting it to show up on their calculator? You did this one, right? Which is fine. So you're just looking at everything. You do second square root. Yep, okay. And then in the second one, negative. Yeah, we're sticking those. We're just doing 17 and 19. Second square root. And then if you hit graph, does anybody else need help? We're just looking at the square root, and then we're going to talk about what are the transformation rules that we need to know. The more graphs you played with yesterday, the more it'll be like, oh yeah, that kind of makes sense. So what's the difference? It's a flip over which axis? X-axis, right? So if I put a line right in there, my blue curve is being flipped upside down over the x-axis. So now I'd like you to look at 18 and see what you think happens in 18. So I can just go back. I'm going to keep the first equation the same. And in the second equation, I'm typing in the square root of negative x. So square root of negative x. and then hit graph. This time it should be flipped over the y-axis. So see how the blue curve, if you folded it this way, so it's reflected over the y-axis. So flip over the y-axis. And I wanted to compare in number 19, why 8 and 16, we couldn't see anything, but in 18, we could, right? In 18, our graph went from this direction to this direction, right? So why could we see the difference here? But in 16, right, I couldn't see anything. It basically looked like just the same V-shaped graph, if those of you that did it. And then in number 8, kind of the same thing was true. In number 8, you just saw this same parabola trace on top of itself. So the reason for that, if I kind of compare for you this function, this function, and this function, what do the first two functions have in common that the second function or third function does not have in common? So how come when I did the reflection, this looked the same, this looked the same, and this went in this direction? Why? What is different about these two graphs that this one doesn't have? Why do I see this green graph here? In these, I really didn't see the green show up. They were already symmetrical. Like if I fold it in half, that leg is already sitting over there. So when this leg moves over here, over the y-axis, it lands on top of itself. So because these two already had that symmetry, sometimes we don't see any transformation, but we do see a transformation on this problem. Does that kind of make sense? So that was what I wanted you to kind of conclude on number 19. Why didn't you see a difference? So I would say that 8 and 16 had y-axis symmetry. So showed no change. Right? So because they had y-axis symmetry, when I do a reflection over the y-axis, you would not see a change. So kind of the big ideas were, let's flip back. What happened in example 1? X squared plus 1, we said went up 1. What do you think is making it move up 1? This guy right here. Why do you think number 2 went down 3? This -3 right here, right? So these to me make perfect sense in my head. Up means plus, down means minus. To me, those are very straightforward. The confusing ones to me are the left and the right. In your brain, what does plus want you to do? X plus 2, where do you think that moves? Right or left? I think it moves right, but what did your graph show you that happened? Your graph on number 3, are you guys looking at your number 3 or are you just staring up here? What did you put for number 3 yesterday? When you put it in parentheses, it should have moved to the left, right? This one moved left 3. Let's think about why that is. When I plug in what value for x, do I get 0 for y? What does x have to be to get 0? See how it's -2? When I plug in -2, do you see how I get 0? That's why -2, 0 has moved to the left. And that's the vertex of the graph. I mean, this one, same thing. X minus 1, I really want to move to the left, but where did your graph move? Your graph actually moves to the right. Did everybody see that when they graphed it? This one moved right 1. Well, think about it. When you plug in +1, what value do you get for y? 1 minus 1 is 0. So 1, 0 is my x-intercept. So what I always tell students is when you're inside a parentheses or you're inside any of the functions, let's say you're inside absolute value, you are inside a quadratic, you are inside a square root. Those all mean move to the left. So I tell students, you're inside, it's the strange world where everything is just backwards. So a +3 actually moves you to the left. And that's the hardest one for students to accept. They don't want to accept it, but we showed on our graphs that happened. And then just if I look through these other two, when I had a number 2 or a 1/3 in front, it should have made number 5. If you didn't get to do it, at least you'll have 1 through 8 filled in. So number 5 would be steeper. So it should have been getting steeper, steeper. And 1/3 should have made your graph like flatter, like that, less steep. Is that what people got who did it? Okay, and then number 7, this flipped the graph upside down, right? So this should have been a flip over the x-axis. And then this one, most of you put no change. That's fine. If you want to add that it would be a flip over the y-axis, that's actually what was happening. So at least if all of you have seen 1 through 8, you've seen enough. 9 through 16 was the exact same set of questions, kind of using absolute value instead, showing you that it doesn't matter what function I use, it shifts it left or it stretches it. So I wanted to look at this resource page to put it together for you here before lunch. There's actually not much that we need to write on here. This resource page is already done for you. So I didn't want you to have to copy it all down. So it just tells you, how do I move right or left? This is resource page 2-4. There's literally nothing that we need to write down. I just want to show you what's on the resource page. Your right and left shifts are the minus or the plus inside the parentheses, and then I've given you an example of what the graph would look like. So this is, you can flip back to this for all of your transformation questions. So then below that is your up and down, like the +2 or the -2 outside, right? And then there's my plus, there's my minus, shifting up or down. So then the next page, there's nothing to write on this either. This is showing you when you put a negative in front, it flips it upside down. When you put a negative inside a parentheses, it basically shows no change because it's over the y-axis. You may want to add for yourself, no change only if symmetrical over the y-axis. So this is on resource page 2-5, but you can add anything you want, anything that makes it clearer for you, because you'll be able to use this on the test. And probably part 1 will ask you some transformation questions without your notes, but it would be nice to have these, you know, for part of the test. And then the bottom 2, they just tell you, oh, this got screwed up when I printed it. Vertical stretch. I tried to make the margins smaller, but it's making it steeper. Instead of calling it vertical stretch, I like to call it steeper or less steep, because some students don't know what vertical stretch means. If you guys were going through a vertical stretch, it just means you're getting taller. You guys what? Get taller till you're about what, 18 or 22? Then when you hit your 40s or 50s and your bones start compacting, you go through a vertical shrink. So enjoy your height in your 20s. Drink your milk for your strong bones. That actually happens. Do you guys realize that? Your grandparents shorter now than they were, when they were young? You do. Your bones compact a little bit. You lose a little bit of height. I went from 5'3.5" to 5'3". They told me in my last appointment, I'm like, I'm sorry, you're really only 5'3" now. And I'm like, are you kidding me? I was always 5'3.5". I'm sure. I'm like, oh, not even 40 yet. My bones can't be compacting. Okay, the next page, I do want you to fill in a little bit about absolute value function, and then we're going to do some practice after lunch. But absolute value is one of the parent functions that you kind of need to own. Some of the other ones, like exponential, I just need to recognize that that's exponential, or I just need to recognize that that's a cubic function, but I don't need to own everything about it. I'm not going to graph it by hand or shift it. Absolute value is the vocabulary word, absolute value. And you guys need to own this function just like you owned linear last unit. This is R26. I just wanted to show you that the other resource pages are there, but I didn't want to spend time creating them. We already did the exploration, so now I just printed them for you as a resource. Okay, the definition. It is a function y equals absolute value of x. And what it means is the distance a number is from 0 on the number line. That is the true definition of absolute value. The distance a number is from 0 on the number line. So if you're doing the absolute value, you're doing what is the distance. So even if I'm walking backwards, like if I go backwards 3 steps, I just walked a negative distance. But I really did walk 3 steps. Characteristics. I want you to put the domain and range. Domain is all real numbers. The range is y is greater than or equal to 0. And it has a vertex. So I want you to write down that its vertex is at 0, 0. So the vertex is that special point that we're going to shift up, down, and around. So those are kind of characteristics about absolute value. And then I wanted us to make a table of values for x and y. So let's go from -3 up to +3 and just fill in what would those coordinates be. If I went from -3 to 3 for x, what did we say it does? It just gives you the positive output. So -3 would become +3. +1 would become +1, right? So all of the y values are just the positive of their partner x. Some students get confused and they think it means opposite. +1 is still +1. +2 is still +2. Don't make them opposites. It's the distance. So they're all positive. And then I want you to just sketch that V-shaped graph using like the straight, you can use a straight edge or just make it a straight set of points, but that's absolute value graph. It's different from the quadratic graph. Any additional thoughts? I don't really have any additional thoughts. So I'm going to skip. I left it there, but there's some things that I don't really need to add anything to. So if you just want to flip to, you can take a couple-minute break, or you can start on page 204, but I want to show you what you're jumping into after lunch. Oh, actually, you know what? After lunch, I want you to be able to do the practice. Let's do one column of this together before lunch and one column after lunch. Page 204, transformation rule practice. If I do the left, you can probably do the right after lunch. So I picked 2 random functions up here, x cubed and absolute value of x. So I'm going to go through the left column, then you can just after lunch do the right column on your own. So if I want to shift something up, I like writing y equals better than f of x. So I'm just going to write y equals, Hallie, give me your favorite number. So x cubed plus 7. This is 204 transformation rules practice. I'm just going to do the left column or a couple of the problems and we'll jump in after lunch. I thought it was guided practice. I think you need help. All right, Matt, what's your favorite number? All right, so we're going to go y equals x cubed, but down 22. So that's up and down, up 7 or down 22. This is a cubic function. Doesn't matter what I put here. This is still up and down. Jill, what's your favorite number? Don't have one? No? 3? 3 is a good number. All right, y equals, so this is going to be in parentheses x minus 3, and you cube the outside of the parenthesis. So x minus 3 goes to the right, and then the cube makes this problem an x cubed. And then I'll just do this last one before lunch, and we'll come back to it. Who else wants to give me their favorite number? Who's excited about a number? Okay, Poppy. 8. Y equals x plus 8 goes to the left, and then I'm cubing it. These are all cubic functions. But do you see how these look very different than these? So your brain needs to recognize, when am I going up or down, and when am I going either left or right inside the parentheses where everything is backwards. This is right, this is left. So it's going to take a lot of practice, but by Wednesday of the week we get back, we're going to get good at our transformation rules. Okay, so let's write these last couple. I've got a couple more favorite numbers if your number isn't up there, but for the reflection piece, the negative sign goes in front of the function. So you could just write the negative and then the x cubed. To me, that just means you're making the entire function negative. Everything is being made negative. When you put it in the parentheses, because these are kind of hard to figure out which is which, you're only making the x's negative. So what I think about is, if I'm over here and I'm making these x's negative, now I'm flipping over here. But if I'm making the entire function negative, now I'm flipping the entire function upside down. So this is like the negative is on the outside of the function. This one, the negative is only with the x's. So the x's are going from here to here. This kind of looks like a mean guy with his eyebrows and his eyes. Okay. Give me your favorite number. Who wants their number? 5. All right. Someone was ready. So that's what my fourth block says every day, and then they make me turn on the fan in the window. You guys really do think that, huh? I thought it was just them. 5 in front of the x cubed. All right, one last favorite number. 12. All right, so if it is a vertical shrink, though, it would be the fraction 1/12, which means it's less tall. This is 5 times taller. Imagine if you were 5 times your own height. You'd be 30 feet or 25 feet tall, right? This is 1/12 of your height, right? So that's a lot shorter than what you currently are. So taller or shorter, think of it as you getting taller or shorter. So now I would like you to go through, and you could almost use the same number if you want, but just practice writing it with absolute value for a minute before I write all of these down. So if you want to keep the number the same and just change the function. So take 30 seconds. What? Okay, I'll do the first one with you. Y equals the absolute value of x plus 7. Shifts that function up. Let's just put them together. Y equals the absolute value of x minus 22. And then in your head, practice. Okay, that shifts it down. How would I write it with absolute value? Y equals the absolute value of x minus 3. And what does the minus 3 do? Shifts it to the right. So I'm just thinking in my head as I write these down. Y equals the absolute value of x plus 8. Shifts it to the left. So up and down are obvious. Plus 7 minus 22. The right and the left are confusing. But as long as you remember it's the opposite of what you think, this goes to the right and this goes to the left. And it's because of where your x-intercept is. Reflection over the x-axis, it's a negative in front of the absolute value. Over the y-axis, it's a negative inside the absolute value. And then vertical stretch, 5 times the number, or 1/12 times the number. So that's it. So our goal is to be able to write the equation from the graph and write the graph from the equation so that you know the transformation rules really well. So if you think about all those 8 rules, you have to learn 8 rules. But then if you think about in math, all of the functions that you can now graph if you know those 8 rules, we have linear, quadratic, cubic, x to the 4th, x to the 5th. You could keep going on bigger polynomials, square roots. We have rational functions that we're not studying this year, exponential functions, absolute value functions. In trig, you'll learn sine, cosine, and tangent functions. These all obey the same 8 rules. So you only have to learn your transformation rules once, and it's those 8. Up, down, left, right, flip, flip, stretch or shrink. So think about those 8 rules are really powerful. Once you know those 8, you're good for the rest of the year. You're going to be able to graph quadratics, exponential and log functions. So it is an important set of rules. So while I am walking around and helping you, I'd like you to try 1 through 14 on the next page. All you have to do is identify what is happening in the function. And I would draw an arrow. So let me just show you like example 1 and 2. I'm going to draw an arrow to this 4 and to this 6. What are they doing for a job right now? What does the 4 do? And what does the 6 do? What do you think? So they each have a job. Is it up, down, left, right, stretch, shrink, or flip? What does the 4 do to the function? It's stretching it, right? 4 times as tall. All right, what does that plus 6 do? Is that up, down, left, or right? If it's a plus 6 and it's outside of the parentheses. Up 6. Okay, let's do 2 more together, and then you're going to try them by looking up the rules. I've got a negative and I've got a 3. So those are 2 different things that are happening. What? Nope. Well, what about down? It's not actually shifting the function down. It's getting stretched. That's what the 3 is doing. It's actually getting taller. Yeah, closer, right? Stretching as I go up. What does the negative do? That flips it over one of the 2 axes. It's actually over the x. It's all the way upside down. So it's a flip over the x-axis. So you're going to draw an arrow all the way down the page. There's like 2 things, I think, for each like question. Some of them might only have 1. Like number 9 only has 1 thing going on. Number 12 only has 1 thing going on. So see if you can do that all the way down. Take the time to flip back and forth and practice, and then we'll put the answers up in about 5 or 10 transformations and doing a quiz on Wednesday. So let's see, this goes to the right. So just do a quick check for yourself. This goes up. This is a shrink, so it's less tall, or you could say less steep. This is up 8. Okay, this is really the graph of 2 to the x. 2 to the x is the function. So the only thing that has changed is this little plus 7, and that's kind of like going left or right. It's in parentheses kind of because it's in the exponent. So this guy just goes left 7. You don't have to say that it was stretched. We're going to learn when we study exponential functions, if you want to stretch it, you have to put like a number in front of the function to stretch it. So this one, I could write it like this. It might make it easier for you to see that this is just up 3. So it's vertically shifting it up 3. Up or down, it's going up. This one is going to the right, because it's like it's inside these parentheses. It's next to x inside the function. This is a flip. So if I think about, I'm going to take all my x's and make them negative. I just rotated around the y-axis, right? So this is a flip over the y-axis, and this would be up 7. At least if you didn't do it, while I'm going over it, does it make sense in your head of where I'm getting these answers from? This plus 4 is inside the function, so that goes to the left. Plus 4 goes to the left. This is a stretch because it's multiplied by 4. This is a down 10, minus 10 on the outside of the function. This is inside the function with x, so this is going to the right. And this is outside the function, so up 8. We're going to do a lot of graphing with quadratics. So you're going to learn what that means is you take your parent function, you go right 4, up 8, and now your function is up here. So it just takes your original parabola and shifts it up here. This one goes down 2. This is a linear function. We call that the y-intercept. But really what you're doing is you're taking the original function and you're shifting it up 8 units. So it's going up 8. And then we call this the slope, but this is actually a flip over the x-axis, and our slope is steeper, right? Because my original function looks like this. So this is flipping it and making it steeper in the negative direction. So you can use it even for linear functions. All right, I think you guys have had it.